सो हामी इथर च्याप्टर पढिरहेको थियौँ। सो इथर च्याप्टरमा हामीले त्यसको फर्स्टमा इन्ट्रोडक्सन, सेकेन्डमा क्लासिफिकेसन, नोमेनक्लेचर एन्ड आइसोमेरिज्म कुराहरू कभर गरिसकेका छौँ। सो अब स्टार्ट गरौँ प्रिपरेसन अफ एलिफेटिक एज वेल एज एरोमेटिक इथर। सो एलिफेटिक कम्पाउन्ड भनेको के हो, एरोमेटिक कम्पाउन्ड भनेको के हो, त्यो हामीले योभन्दा पहिलो कुरा भिडियोहरूमा हेरिसकेका छौँ। सो एलिफेटिक भनेको नर्मल कम्पाउन्ड विदाउट ह्याभिङ बेन्जिन रिङ इन सिम्पल वर्ड, whereas aromatic compounds are those compound in which benzene ring is attached to a functional group. So यो दुईटा सेम वे विलियमसन synthesis reaction. So using Williamson synthesis we can prepare both aliphatic as well as aromatic ether. So first यसमा के हुन्छ भने haloalkane were used as a substrate. So haloalkane is reacted with sodium or potassium alkoxide when haloalkane, that is Rx, where X may be chlorine, bromine, iodine. So when haloalkane is treated with sodium or potassium alkoxide, that is RONA or ROKA, ROK. So these are potassium and this is sodium alkoxide. So when this haloalkane is treated with sodium or potassium alkoxide, it gives ether. So this reaction is known as Williamson's synthesis. So it is generally used to prepare both symmetrical as well as unsymmetrical ether. So यो अघिल्लो भिडियोमा हामीले सिमेट्रिकल इथर के हो एन्ड अनसिमेट्रिकल इथर के हो त्यो हेरिसकेका छौँ। इथर ह्याभिङ सेम नम्बर अफ कार्बन in their both side, that is left and right side, are called as symmetrical ether, whereas if the number of carbon atom on the both side are different, then they are considered as unsymmetrical ether. So our reaction arrow, when Rx, that is haloalkane, is treated with sodium alkoxide, it gives ROR plus salt of sodium, that is X. So यसमा के हुन्छ भने these are went to react with this RO and the Na will react combine to X. So यो चाहिँ हाम्रो mechanism हुने हो for Williamson synthesis reaction. So for example CH3 CH2 Br. So it is the haloalkane containing bromine as a halogen group plus CH3O and A, which is sodium alkoxide. So it will give CH3 and CH2 from this, then oxygen and CH3 plus NaBr. हेर्न सक्छौ this CH3 CH2 and from here this CH3ONA is this. So remaining Na and Br form NaBr. So this is the general example of Williams synthesis reaction. Now so you चाहिँ aliphatic compound बनाउने तरिका हो. Now for the aromatic compound, haloalkane, the haloalkane use गर्ने हो haloalkane, but it is treated with sodium phenoxide. Sodium phenoxide भनेको sodium phenoxide is an aromatic compound in which the ONA, that is the functional group ONA, is attached to a benzene ring. So इसको structure मैले sodium phenoxide, that is haloalkane is CH3Cl plus sodium phenoxide भनेको benzene ring. Here ONA. So this is sodium phenoxide. So when these two are treated, यसले दिने भनेको यहाँको बेन्जिन. So benzene of this along with O gives CH3. So we can say this and this combine together to give a aromatic ether. अनि बाँकी भएको Na and Cl combine together to give salt. So you चाहिँ aromatic. This is the process for the manufacturing of or preparation of aromatic ethers. Now talking about the physical properties of ether. So ether generally हामीले methoxymethane, that is CH3O CH3 methoxymethane methoxyethane. So एकतिर C2H5O CH3. This one is methoxyethane. So generally these two are colorless gases. That means हामीले यहाँबाट हेर्न सक्छौँ कि they are gases in state and colorless. Other members are colorless volatile liquid with pleasant odor. So यो दुईटा बाहेक सबै चाहिँ लिक्विड फर्ममा हुन्छ, बट कलर चाहिँ सबैको कलरलेस नै हुन्छ. So they have no color. Next is ethers are soluble in water. Insoluble in water. So ether is a type of organic compound which are insoluble in water. यसको रिजन के हो? यसले इंटरमोलिकुलर H बन्ड बनाउँदैन. जेनरली इनसोल्युबल भनेपछि हामीले त्यो कुरा याद राख्नै पर्ने हुन्छ. इंटरमोलिकुलर H बन्ड बनाउँदैन. The next is they have lower boiling point than corresponding alcohols due to the absence of intermolecular H bond. So solubility and boiling point दुईटै कुरा भने हामीले यति भन्न सक्छौँ कि if any compound does not form intermolecular hydrogen bond or simply intermolecular H bond with water, then they are insoluble as well as their boiling point is lower. Alcohol ले बनाउन सक्छ, that's why their boiling point is greater than ether. Now chemical properties. So chemical properties मा हामीले इथरलाई फर्स्टमा HI सँग रिएक्ट गराउँछौँ, देन आफ्टर HCl सँग रिएक्ट गराएर हेर्छौँ, देन आफ्टर H2SO4 सँग हेर्छौँ, देन Cl2 एन्ड एयर सँग. सो हामीले यो डिफ्रेन्ट कम्पाउन्ड सँग व्हेन इथर रिएक्ट यसले कस्तो प्रोडक्ट दिन्छ त्यो कुराहरू हामीले हेर्ने हो. सो फर्स्ट व्हेन इथर रिएक्ट्स विथ कङ्क HI टु गिभ एल्कोहल एन्ड अल्केन. सो इथरलाई HI सँग रिएक्ट गरायो भने यसले दिने भनेको फर्स्ट एल्कोहल दिन्छ, अर्को भनेको अल्केन. सो यसको मेकानिजम हेरौँ. सो वान action with HI. So ROR, this one is ether plus HI. यो भनेको रिएक्टिङ कम्पाउन्ड. यसले दिन्छ के भने फर्स्टमा एल्कोहल एन्ड द अल्केन. So it gives this RO combined with this H to give ROH. बाँकी के भयो? This R and this I. So it gives RI. So यहाँबाट हामीले हेर्न सक्छौँ कि हामीले हेर्न सक्छौँ फर इक्जाम्पल C2H5O again C2H5. So this one is ethoxyethane or for common name diethyl ether plus HI. यससँग रिएक्ट गरायो भने यताको जुन छ लेफ्ट साइडको O सहित यसले H सँग बन्ड बनाइहाल्छ and it will give C2H5O and H will be added. So you alkyl, alcohol. The next is remaining के कैसा है C2H5 and I. So it form C2H5I. So this one is halo alkane. So first reaction ये हो कि when ether reacts with HI it gives alcohol as well as haloalkane. Now our conditions when in case of unsymmetrical ether, so you चाहिँ के छ symmetrical, here C2 and here also C2, so this is symmetrical. So if in case there is unsymmetrical ether, so कुनले halide formation गर्ने कुनले alcohol formation गर्ने त्यसको. So alkyl halide with a smaller alkyl group is formed. So halide जुन formation हुन्छ halide haloalkane, त्यो halide formation भनेको सानो ग्रुपसँग अट्याच हुन्छ and the larger group will form alcohol. त्यसको example हेरौँ C2H5O and this one is CH3. So यहाँ चाहिँ this is longer group, this is a smaller group. So यसमा आउने भनेको smaller group सँग I बस्छ whereas larger group सँग H आउने भयो. So larger group form alcohol and the smaller group form halide form, it is haloalkane. The next condition is if the excess of HI is used, the HI को जुन amount छ त्यो access गराइदियो भने के हुन्छ, the alcohol formed above react again with the acid, alcohol जुन formation भएको छ that again जुन यो formation भएको alcohol छ that again reacts with HI and it give alkyl halide. So double दुईटा molecule of alkyl same alkyl halide formation हुने भयो. So त्यसको mechanism here ROR plus 2HI. Since this is excess amount छ भने के हुन्छ, फर्स्टमा ROH formation हुन्छ plus RI. Again if हामीसँग एक्स्ट्रा छ भने again HI गराइदियो भने it will give 2RI plus H2O. So two molecules of halide formation हुने भयो. So here is the example. Ethoxyethane, that is C2H5O C2H5. This reacts with two molecules of HI to give iodoethane plus oxygen. The next example is methoxyethane to give iodoethane and iodomethane. So दुईटा this is unsymmetrical, त्यही भएर यसले दुईटा different halide group दिने भयो. So this one is one. Now action with conc HCl and conc H2SO4. So हामीले HI सँग reaction गरायो भने हेरिसक्यो. Then after त्यसको तीनटा condition, when simply गरायो भने alcohol and halide, if हामीसँग unsymmetrical छ भने longer ले alcohol and smaller ले halide, and the next condition is if the excess amount of HI is used, then the both will be halide form, halide group is formed. Now action with conc HCl and conc H2SO4. So ether dissolve in cold conc minerals acid to form oxonium salt. So when हामीले etherलाई conc H2SO4 as well as conc HCl दुईटैसँग एड गरायो भने यसले दिने भनेको oxonium salt हो. So two different oxonium salts are formed here. So example ethoxyethane. Generally हामीले use गर्ने भनेको second दुईटा कार्बन भएको group, that is symmetrical ether, that one is ethoxyethane. So when ethoxyethane reacts with conc H2SO4 at cold temperature, it gives here HSO4 ion, and the next ion will be oxonium salt ion, that is diethyl oxonium hydrogen sulfate. Similarly हामीले यहाँ कङ्क एचसिएलमा पनि त्यही हेर्न सक्छौ, डाइइथाइल अक्जोनियम क्लोराइड सबै कुरो सिमिलर छ, CH3 CH2O CH2 CH3, जस्ट यहाँको एउटा C यहाँ आइदिन्छ, H अल बाँकी सबै यहाँ Cl मात्र रिमेनिङ, सो Cl माइनस, हेयर यहाँ दुईटा 2H छ, एउटा H यहाँ गइदिन्छ टु फर्म अ oxonium salt and the remaining HSO4 is here. So this is the action with conc HCl and conc H2SO4. Now action with air. Air भनेको O2. So action with O2. When ether reacts with air in presence of light form a ether peroxide. So when ether, हामीले etherलाई generally in presence of sunlight एटमोस्फियरको जुन अक्सिजन छ O2 त्योसँग रिएक्ट गरायो भने यसले दिने भनेको ROR plus O2 in presence of light, it gives ether peroxide, that is ROR. So यो बन्ड फर्मेसन हुने भयो, so it is called as peroxide. For example, C2H5 oxygen, C2H5 in presence of oxygen and light हामीले पाउने भनेको C2H5 and the peroxide bond will be formed. So this is considered as ether peroxide. Ether peroxide. So action with O2 यस्तो हुने भयो, it will give peroxide. Ether peroxides are generally explosive and thermally unstable, so it is dangerous to distill old sample of ether. So यसको यो स्मल क्वेसन, सर्ट क्वेसन आउने क्वेसन हो. So why ethers are dangerous to distill the old sample of ether? यसको मेन रिजन भनेको जुन फर्मेसन हुन्छ अक्सिजनसँग रियाक्ट गरेर इथरले इथर पेरोक्साइड फर्मेसन गर्छ, एन्ड द इथर पेरोक्साइड आर एक्सप्लोजिभ इन नेचर. यसको नेचर चाहिँ एक्सप्लोजिभ हुन्छ, द्याट्स वाइ इट इज डेन्जरस. नाउ एक्सन विथ क्लोरिन. सो क्लोरिनसँग वेन इथर, इक्जाम्पलबाटै हेरौँ, when C2H5, that is ethoxyethane, when ethoxyethane reacts with chlorine in dark condition, अक्सिजनसँग लाइट कन्डिसनमा छ भने क्लोरिनसँग डार्क कन्डिसनमा. सो यस्तो बेला यस्तै दिने भनेको यसमा यसको अलिक कन्डेन्स्ड फर्म लेखौँ, CH3 अटाउँदैन होला, सो हियर CH3 CHO CH Cl3. यहाँ हेर्न सक्छौ कि यहाँ जुन एक्स्ट्रा एच हुन्छ, डबल दुईटा एच हुन्छ, यसको कन्डेन्स्ड फर्म भनेको CH3 CH2O CH2 CH3. सो यहाँ जुन दुईटा हाइड्रोजन हुन्छ, यहाँबाट पनि -1 हाइड्रोजन, यहाँबाट पनि -1 हाइड्रोजन एच. सो यो यहाँ जुन एउटा हाइड्रोजन रिप्लेस हुन्छ विथ क्लोरिन एन्ड द एक्सन विल बी H2. सो यो चाहिँ एक्सन विथ क्लोरिन. सो वेन इट रियाक्ट्स विथ क्लोरिन एट डार्क कन्डिसन, इट गिभ दिस प्रोडक्ट. सो इट इज कल्ड एज diethyl ether. So it is called as diethyl ether. Similarly, the next one is here. यहाँबाट if excess, this is when limited amount of Cl is used. when the amount of chlorine is excess excess amount गरायो भने सबै H is replaced with Cl हेर्न सक्छौ कि सबै यो this one this all are chlorine so सबै H got replaced with chlorine atom and it is called as perchlorodiethyl ether so इसको C C O C and C so it will be Cl 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 again same this side Cl Cl so it is called as perchlorodiethyl ether so this is the action with chlorine now the uses of ethoxyethane so uses so ether भनेको हामीले जनरली युज गर्ने भनेको इथोक्सिइथेन द्याट इज C2H5O C2H5 जनरली हामीले इथोक्सिइथेन नै युज गर्ने भनेर त्यसकै सम युजेस यहाँ देखिएको छ सो फर्स्ट it is used as industrial solvent so हामीले इथोक्सिइथेनलाई इन इन्डस्ट्रिज एज अ सल्भेन्टको रूपमा युज गर्न सक्छौँ which is used to dissolve or make soluble other organic compounds so they are industrial solvent next one is anesthetic agent so हामीले इथोक्सिइथेनलाई एज अ anesthetic agent पनि युज गर्न सक्छौँ so it can be used to give anesthesia the next is refrigerant यो हामीले रेफ्रिजरेसन साइकलमा पनि युज गर्न सक्छौँ टु कुल and the next type is it is used as a solvent for many reactions as Wurtz reaction, Fittig reaction or the preparation of Grignard reagent. So ethoxyethane लाई हामीले as a solvent पनि use गर्न सक्छौँ for the preparation of for the different many reactions such as Wurtz reaction. So तीनटा reactions छ that is Wurtz reaction. Next is Fittig reaction and the last one is preparation of Grignard. So यो तीनटा कन्डिसनमा पनि हामीले इथोक्सिइथेनलाई युज गर्न सक्छौँ सो युजेस सँगै हामीले यो इथर च्याप्टर यही सघाउँछौँ सो थ्याङ्क यू यसपछिको अर्को च्याप्टर सँगै अर्को भिडियो साथ आउनेछ